Hello, we are going to start our lesson on applications of differentiation. Okay, applications of differentiation. And then what we are going to write the gradient function. Okay, the whole concept of differentiation is that when you are given a function and you differentiate. When you differentiate the function, what you get is the gradient function. Is the gradient function. Alright. So if I have a function y is equal to, let's say the function is quadratic, let's say as squared plus bs plus c. If I differentiate this function, which is quadratic, where a, b, and c are constant, that is dy dx, which will give me 2ax plus b. 2 multiply a, subtract 1 from here, and then the c will be 0. Okay, so when I differentiate a quadrant, you see that I'm getting a linear function. Okay, so when I differentiate this, the differentiation of this particular function I get here is called what? The gradient function. The gradient function. And this gradient function, it will be the gradient at a point on the, if it is quadratic, then it will be at a point on the what? On the curve. So at any point on the curve, okay, if I substitute, let's say the value of x, okay, into this particular function here, okay, it will give me what? The gradient at that particular what? At that particular point. All right. So let's say that I have my function is quadratic. So when you draw quadratic, you are going to get what? Quadratic will give you a curve like this. And take, if it is cubic too, you are going to get what? You are going to get a curve. All right. And I'm going to find the gradient at a point on this particular curve. So let's say I have a point here, and I want to find the gradient on this particular point. Okay, so what you should take note is that the moment I differentiate this particular quadratic, okay, y is equal to, when I differentiate this quadratic here, I'm going to get a linear function. So if I'm finding the gradient at a point on this particular curve, and the normal time, if I'm supposed to illustrate, you see that I'm going to draw a line. I'll draw a line like this, and the line will touch, okay, the line will touch the curve at this particular point. So let's say at this particular point, my point x1, say y1, this is my point. Okay. So when I want to find the gradient of this line at this particular point, say s1 and y1, if I substitute the value of x into the gradient function, then I'll get the gradient of this particular line. Okay, so the gradient function, okay, gives you the gradient of any point on the curve. So let's say I want to find the gradient at this particular point, then I'll draw a line. This is my line. Then I'll find the y on the s on this particular line. Okay, so when you find the y on the s of this particular line, you will see that you will get a gradient. Okay, so the moment you differentiate this particular function, whatever you get here has now become the gradient function. So if I'm finding the gradient at a point on the curve, let's say at point s is equal to 2, then with this my differentiation, when I substitute there, it will give me the gradient of this particular line at this particular point. Okay, and this particular line, take note, because the line is touching the curve at the point, this line is called what? Tangent. This line is called tangent. Okay, so this particular line, I can say the gradient of a tangent at a point on the curve. Okay, the gradient of a tangent at a point. So it can be depending on how. Sometimes you can even be given a linear function. Say y is equal to ax. Let's say if I have ax plus b, then what will be my dy on the x? My dy on the x will be what? Will be a. This will become 0. Could you remember, if you have done coordinate geometry, okay, how do you find the gradient when you are given a function? Let's say I have y is equal to 5s plus 3. How do you find the gradient? We say that the gradient is the coefficient of the x. So this is the gradient, and this is the y-intercept. Is that not so? Okay, so this is the gradient. Okay, this is the gradient, and then this is the y-intercept. At the y-intercept, s is what? S is 0. So if I put s is 0, I get y to be equal to 3. Okay. So this becomes the gradient, and let's differentiate the function there. What is dy on dx? That is 5. Okay, and you see that this will be 0. When I differentiate, it becomes 5. So even if it is what? If it is a linear function, you can also get what? Get your gradient, because the gradient is the coefficient of the x. Okay, so anytime you have a particular function and you differentiate, what we are saying that whatever you differentiate, you get a gradient at a point on, if it is a curve or whatever it is. Okay, at a point you get a gradient at that point. So I'll also be giving the gradient. Okay, and then you can be asked what? To find the value of x and y. Okay, so when you are giving the gradient, they are asking you find the value of x and y. Okay, so you are finding the point. Okay, the point at where you will get what? The gradient. Okay, that particular point where if I draw a tangent to pass through that point, there you are giving the gradient of the tangent, and you are asked to find the point through which the tangent passes to get what? To get a gradient. All right. Okay, so you differentiate, equate it to what? Equate it to the gradient, and then you find the value of s. Then to get the value of y, you take x and you substitute into the main function, and then you get the value of what? You get the value of y. Okay, so all that we are saying that when you differentiate a function, it will give you the gradient function. So now let's solve some questions right away. All right. Okay, so let's look at the questions. 1. If y is equal to 2x squared minus 3x plus 5, find the gradient at s is equal to 2. So we are going to do them one by one and follow carefully. Simple to understand. So number 1, y is equal to 2x squared minus 3x plus 5. We are going to what? Find the gradient as s is equal to 2. We are going to find the gradient. So this is quadratic, so it's going to be a curve, and you are finding the gradient at the point where s is 2. Okay, at the point where s is 2. So you are finding the gradient of the tangent. So what we have to do is to differentiate this. So dy on the x will be equal to what? 4x minus 3. 4x minus 3. And then you are finding it at s equal to 2. So you say that at s equal to 2, okay, the gradient is equal to 4. You substitute 2 here by 2 minus 3. Then 8 minus 3 will give us 5. Will give us 5. So at a point on this curve, okay, and at that point where s is 2, the gradient is what? The gradient is 5. Okay. Number 2, find the gradient of the curve y is equal to s minus 3 multiplying s squared plus 2 at a point s is equal to 1. Okay, s is equal to 1. We are going to find the gradient. Okay, so our y is equal to what? X minus 3 and then s square plus 2. If you like, you can use the product rule where you differentiate this and maintain this plus differentiate them, or you can expand and then we go by a normal differentiation. Okay, so let's expand. Y is s times x will give me s cube, s times s square is s cube, s times 2 will give me plus 2s, minus 3 times s square will give minus 3s square, and then minus 3 times will be minus what? 6. So I can write it as y is equal to s cube minus 3s square plus 2x minus 6. Alright, so s times s square is s cube, s times 2 is 2x, minus 3 times s square is minus 3s square, minus 3 times 2 is minus 6. So now let's differentiate the y on the x. Will give me what? 3s square and then minus 2 times 3 minus 6x, okay, plus 2. So at x is equal to 1, what to be our gradient? Our gradient will be 3 times 1 square minus 6 times 1 plus 2. So you substitute 1, okay, at wherever you see x. So 3 times 1 square will give me 3, minus 6 times will give me minus 6 plus 2, and then 3 minus 6 is minus 3 plus 2 will give me minus 1. Okay, so at s equal to 1, the gradient, okay, at a point on the curve s equal to 1 is negative 1. It's negative 1. All right. Okay, so let's see the number 3. Number 3, find the gradient of 2s squared plus y squared equal to 6 at the point where x is equal to 1. So we have 2s squared plus y squared equal to 6. So this one we can use what? Implicit. Okay. So then we differentiate 2 times 2 give me 4x plus 2y dy on the x, and this one give me what? 0. All right. So I'll make dy on the x the subject, so that I have 2y dy on the x to be equal to negative 4x. So that I have what? My dy on the x to be equal to what? Minus 4x on 2y. Okay, minus 4x on 2y. So I have to substitute, this is the gradient function. So I have to substitute x equal to 1. But what is the y value? So to get the y value, we have find the gradient at the point where x is 1. So we have to get the corresponding y value. And at that point, we have to substitute 1 into what? Into the main function. And then we get the corresponding value of what? Value of y. So that we can know the point on that particular curve. Okay. So, we have at s equal to 1, we have what? 2 times 1 square plus y square equal to 6, and then 2 times 1 square will give me 2 equal to 6, and then my y square is going to be what? 6 minus 2, and then my y square will give me what? 4, and my y will give me what? My y will give me square root of plus or minus 4, and that will give me plus or minus 2. Okay, so my y can be positive 2 or what? Or negative 2. That can be my y. Alright. So we have two values of y, negative 2 or positive 2. So it's that gradient at what is x? X is 1. And then if y is 2, it implies that or is equal to minus 4. What is the x? 1 divided by 2. What is the y? 2. So minus 4 on what? On 4. That will give us negative 1. And also gradient at x is 1, but y is what? Y is negative 2. That will be 4, negative 4 times 1 over 2 by negative 2. Negative 4 times negative 4. 2 by negative 2 give negative 4. And then that will give me positive 1. Okay. That will give me positive 1. So the gradient values will be 2. Either negative 1 or what? Or positive 1. Depending on what? On the y value. Either y is 2 or minus 2. Is that okay? Alright. So let's look at the last question. Okay, so let's look at the last one. Find the coordinates of the point on the curve. Y is equal to x plus the all square at which its gradient is negative 2. At which particular point on the curve is the gradient going to be negative 2? So our y is equal to what? S plus 3 all square. So let's differentiate. So the y on the x. If you like, I use the chain rule. 2 will come here. Then x plus 3. Then you subtract 1 from here. Then you multiply by the differentiation of this, which is 1. Alright. So we are going to have our dy on the x to be 2 times x, 2x, 2 times 3. That is 6 times 1. That will be the same. 2x plus 6. Okay, 2x plus 6. And take note, you also use the normal one, x squared. X times 3 times 2. That will give me 6x plus 9. So that will be 2s plus 6. Alright. Okay, so since this is the gradient function, you equate it to the gradient at negative 2. Okay. It implies that 2s plus 6 is equal to negative 2. And 2s is equal to what? Minus 2 minus 6. And 2s will give us what? Minus 8. And x will be equal to negative 4. Minus 8 over 2. Okay, so x is negative 4. At that point, the gradient is negative 2. But we are finding the coordinate. So you substitute negative 4 into the main function and you find the corresponding y value. Okay, so at s equal to negative 4, y will be equal to what? Negative 4 plus 3 all squared, right? And y will be equal to negative 4 plus 3 will give me negative 1 squared, and that will be 1. Okay, you conclude that the coordinates of the point is equal to negative 4, 1. So s is negative 4 and then y is 1. So the coordinate is negative 4 and 1. Negative 4 and 1. I believe you get it. Okay. So this is how this is being done. Alright. I know I'll see you again as you solve more questions. Okay. Enjoy your day. Bye bye.